Good afternoon students, welcome back to online maths class. So in the last class we have solved up to question number 6 in the exercise 5.3. So in today's class let us continue with the question number 7. The given function is sin square y plus cos of xy which is equals to 5. So we will have to find the derivative of the given function. Let us proceed with the solution. Write the given function sin square y plus cos of xy which is equals to pi. Now differentiate both the sides with respect to x. So differentiate with respect to x. Differentiate with respect to x. Now how do you find the derivative of sin square y? So sin square y can be written as sin y the whole square. Sin square y can be written as sin y the whole square. So we have to find the derivative of this function by making use of chain rule. Consider this as x now. It is in the form of x to the power n. What is the derivative of x to the power n? N into x to the power n minus 1. So here n is 2. 2 into sin y to the power 2 minus 1 into derivative of the inside function. So derivative of sin y will be cos y into dy by dx. So here 2 minus 1 it will be 1. So sin y to the power 1 it is sin y. So derivative of sin square y will be 2 sin y. Now derivative of this inside function now sin y it will be cos y dy by dx. Cos y dy by dx plus now derivative of cos of xy. So again we have to make use of the chain rule here. Treat this as x now. Whatever is there inside the bracket, consider that as x. Derivative of cos x will be minus sin x. I will be writing minus sign here. So it is minus sin x. What is x now? It is xy. Now we will have to take the derivative of this inside function. So to take the derivative of this inside function, we have to make use of the product rule. uv the whole dash is equals to u dash v plus uv dash. So I'll put the main bracket here. Now xy, derivative of xy. So this is going to be u dash. Derivative of x it will be 1. Write the second function as it is plus write the first function as it is. Take the derivative of the second function. Derivative of y it will be dy by dx. So close the square bracket now. This is equals to derivative of pi it will be 0 because it is a constant. It is 0. So now simplify this further now. 2 sin y into cos y dy by dx. Then multiply this term with these two. 1 into y it will be y minus y sin of xy. So minus, we get minus y sin of xy. Then minus into plus it will be minus this term into this one. It is x dy by dx into sin of xy into sin of xy which is equals to 0. So now 2 sin y cos y can be written as sin 2y, double angle formula. So this is sin 2y dy by dx, then minus y sin of xy, then minus x dy by dx into sin of xy which is equals to 0. Now in the first term and in the last term we can take dy by dx common and write the remaining terms. So here sin 2y then minus x into sin of xy into dy by dx. This is equals to what we have done here. In the first term and in the last term I have taken dy by dx common, and then now you take this term to the right hand side, it becomes positive. So we get y into sin of xy. Now we want only dy by dx. Take this term to the right hand side. So what do we get now? dy by dx which is equals to y sin of xy, y sin of xy divided by we have to write this particular term sin 2y minus x into sin of xy, x into sin of xy. So this is the required answer for the question number 7. Note down this and take the question number 8 as an assignment. I will be solving question number 9. So from question number 9, we have to go for derivatives of inverse trigonometric functions. So far we have calculated the derivatives of implicit functions. So let us move on to derivatives of inverse trigonometric functions. Question number 9, it is y which is equals to sin inverse, y which is equals to sin inverse, y which is equals to sin inverse 2x divided by 1 plus x square, 1 plus x square. So here we have to solve this by substitution method. I'll take x as tan theta. Put x equal to tan theta or theta which is equals to tan inverse x. This implies theta will be tan inverse x. So let us simplify the given function now. Y which is equals to sin inverse 2. What is x now? X is tan theta. So it is a tan theta. Then divided by 1 plus tan square theta. 1 plus tan square theta. So observe this term now. 2 tan theta divided by 1 plus tan square theta. This is nothing but sin 2 theta. This we have studied in our first PUC trigonometric functions chapter. So now y which is equals to sin inverse, this is nothing but sin 2 theta. This is nothing but sin 2 theta. So now this is a standard property. We have a property in inverse trigonometric functions, that is chapter 2. Sin inverse sin x, it will be x. Similarly cos inverse cos x equal to x, tan inverse tan x will be x, secant inverse secant x will be x. So that property we have to use now. Sin inverse sin x, what is x now? X is nothing but 2 theta. This is the standard property. So y which is equals to 2 theta. Now replace theta here. What is theta? It is a tan inverse x. So y which is equals to 2, in place of theta I will be writing tan inverse x. So till here we have simplified the given function. Now we will have to go for the derivative. Differentiate both the sides with respect to x now. So differentiate with respect to x. So derivative of y will be dy by dx, which is equals to 2 is a constant, must be written as it is. What is the derivative of tan inverse x? It is 1 divided by 1 plus x square. So into 1 divided by 1 plus x square. Overall the answer is dy by dx. This is equals to 2 into 1 it is 2 divided by 1 plus x square. So this is the required answer for the question number 9. Note down this and then we'll move on to next question. Well, the next question it is 10th one, y which is equals to tan inverse inside the bracket 3x minus x cube divided by 1 minus 3x square. So again we have to solve this by substitution. So here I will be taking x as tan theta. So 10th one, y which is equals to tan inverse 3x minus x cube divided by 1 minus 3x square. 1 minus 3x square. So now put x is equals to tan theta. Put x equal to tan theta. Then now from this theta will be tan inverse x. Theta which is equals to tan inverse x. So now rewrite the given function with the help of this substitution. Y which is equals to tan inverse, y which is equals to tan inverse inside the bracket 3 tan theta 3 tan theta minus x cube means it will be tan cube theta. It is tan cube theta divided by 1 minus 3 tan square theta. So again this is a standard formula that we have studied in our first PUC trigonometric functions. So y which is equals to tan inverse, this is nothing but triple angle formula, tan 3 theta. So tan inverse tan 3 theta. So again this is a standard property in inverse trigonometric functions. Tan inverse tan x will be x. What is x now? Here x is nothing but 3 theta. So y which is equals to 3 theta. Replace theta in the next step. So y which is equals to 3 theta. Theta is nothing but tan inverse x. So it will be tan inverse x. Now differentiate with respect to x. Both the sides we will have to take the derivative. Derivative of y, it will be dy by dx. Now 3 is a constant, we should write it as it is. Then derivative of tan inverse x will be 1 divided by 1 plus x square. Overall the answer it is 3 divided by 1 plus x square. So this is the required answer for the question number 10. So take question number 11 as an assignment. I will be solving the question number 12. So for these two again we have to take the substitution as x equal to tan theta. Well, let us solve the question number 12. Y which is equals to sine inverse, y which is equals to sine inverse 1 minus x square divided by 1 plus x square, divided by 1 plus x square. The substitution remains the same. So with the help of this we will have to rewrite the given function. Y which is equals to sine inverse 1 minus tan square theta, 1 minus tan square theta divided by 1 plus tan square theta. So what is this 1 minus tan square theta by 1 plus tan square theta? This is nothing but cos 2 theta. So y which is equals to sine inverse cos 2 theta. So now we will have to make use of the complementary angle property. Outside we have the sine inverse, that means inside the bracket we should have the sine term, but here we have cos. By making use of complementary angle we can write this in terms of sine. So how do you write that? Y which is equals to sine inverse sine pi by 2 minus 2 theta, sine pi by 2 minus 2 theta. So sin 90 minus theta will be cos theta. Cos theta ne ee form da ಬರ್ದಿವಿ ನಾವು ಈಗ. ಈಗ ಯಾವ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮ್ ದಾಗ ಅದ ನೋಡ್ರಿ, sin inverse sin x. ಇಲ್ಲಿ x ಅಂದ್ರೆ pi by 2 minus 2 theta ಆಗ್ತದೆ ಇಲ್ಲಿ. So y which is equals to pi by 2 minus 2 theta. Now replace theta here. So y which is equals to pi by 2 minus 2. What is theta? Theta is nothing but tan inverse x. Theta is nothing but tan inverse x. So till here we have simplified the given function. Now we are going for actual differentiation. So differentiate with respect to x. Differentiate both the sides with respect to x. We get dy by dx. Then derivative of pi by 2, it will be 0 because it is a constant. Then now write 2 as it is, minus 2 as it is. Then derivative of tan inverse x will be 1 divided by 1 plus x square. Overall we have 2 divided by 1 plus x square. So now 0 minus this term. So dy by dx which is equals to minus 2 divided by 1 plus x square. So this is all about the question number 12. Note down this and then we'll move on to question number 13. Well, the next question it is question number 13, y which is equals to cos inverse 2x by 1 plus x square. So let us go ahead with the substitution. Question number 13, y which is equals to cos inverse cos inverse 2x divided by 1 plus x square. Now again the substitution remains the same. Put x equal to tan theta. From this theta will be tan inverse x. Theta will be tan inverse x. So rewrite the given function now. Y which is equals to cos inverse 2 tan theta divided by 1 plus tan square theta. 1 plus tan square theta. So this is the standard formula now. 2 tan theta by 1 plus tan square theta will be sin 2 theta. So y which is equals to cos inverse sin 2 theta. Sin 2 theta. Outside we have the cos inverse term. That means inside also we should have cos term. So by making use of complementary angle, so we have to change this in terms of cos. Y which is equals to cos inverse, it can be written as cos 90 minus theta. Here theta is nothing but 2 theta. Observe this. Cos pi by 2 minus theta will be sin theta. Then now it is in the form of cos inverse cos x. It will be x. X andre enaguttilla pi by 2 minus 2 theta. So y which is equals to pi by 2 minus 2 theta. Pi by 2 minus 2 theta. So y which is equals to pi by 2 minus 2. What is theta? Theta is nothing but tan inverse x. So it will be tan inverse x. Now differentiate both the sides with respect to x. Differentiate with respect to x. So dy by dx which is equals to 0. Derivative of a constant, it is 0. Then minus 2, write it as it is. Then derivative of tan inverse x will be 1 divided by 1 plus x square. So overall we have dy by dx which is equals to minus 2 divided by 1 plus x square. So this is the required answer for the question number 13. Note down this and then we'll take up question number 14. Well, let us solve the question number 14. The given question is y which is equals to sin inverse 2x into square root of 1 minus x square. Now here we will have to take the substitution as x equal to sin theta, because outside we have the sin inverse term, inside we should have sin term. That is why I am going for the substitution as x equal to sin theta. Put x equal to sin theta. Put x equal to sin theta. Then from this theta will be sin inverse x. Theta will be sin inverse x. Then rewrite the given function. Sin inverse inside the bracket 2 x. What is x now? It is sin theta. Sin theta square root of 1 minus x square. X square means we get sin square theta. Sin square theta. Then y which is equals to sin inverse 2 sin theta 1 minus sin square theta, it will be cos square theta. Square and root get cancels, we have cos theta. Y which is equals to sin inverse, what is this now? 2 sin theta into cos theta, it is sin 2 theta. It is sin 2 theta. Then now sin inverse sin x. What is x now? It is 2 theta. So y which is equals to 2 theta. Replace theta here. Y which is equals to 2 sin inverse x. Theta is nothing but sin inverse x here. Differentiate both the sides with respect to x. So differentiate with respect to x. Dy by dx which is equals to 2, write it as it is. The derivative of sin inverse x will be 1 divided by square root of 1 minus x square. So 2 divided by square root of 1 minus x square. So this is the required answer for the question number 14. Note down this and then we'll take up the question number 15, and which is the last question of the exercise 5.3. Well, write the question number 15. It is y which is equals to secant inverse 1 divided by 2x square minus 1. So outside we have the secant inverse term. That means inside we should have secant term. So in order to get that, we have to take x as cos theta. So put x equal to cos theta. Put x equal to cos theta. From this, theta will be cos inverse x. Theta will be cos inverse x. Then y which is equals to, I am rewriting the given function now, y which is equals to secant inverse 1 divided by 2 x square. X square is nothing but cos square theta. Cos square theta minus 1. Then in the next step, y which is equals to secant inverse 1 divided by, what is this now? 2 cos square theta minus 1. It is cos 2 theta. It is cos 2 theta. In the next step, y which is equals to secant inverse 1 by cos 2 theta will be secant 2 theta. Reciprocal of cos, it is secant 2 theta. ಈಗ ಯಾವ ಫಾರ್ಮ್ ದಾಗ ನೋಡ್ರಿ, secant inverse secant x will be x. ಇಲ್ಲಿ x ಅಂದ್ರೆ 2 theta ಆಗ್ತದೆ. So y which is equals to 2 theta. Then y which is equals to 2, replace theta now. It is cos inverse x. Cos inverse x. Now differentiate both the sides with respect to x. Differentiate with respect to x. So what do we have? dy by dx which is equals to, so now 2 as a constant, write it as it is. Derivative of cos inverse x will be minus 1 divided by square root of 1 minus x square. So 2 into minus 1, it will be minus 2 divided by square root of 1 minus x square. So this is the required answer for the question number 15. So with this we have completed the derivatives of implicit functions as well as the inverse trigonometric functions.